Hello everybody. This lecture we will speak about orthographic projection. This is another type of drawing, technical drawings and figures and plots. Here we speak about something else. In the last drawing, we working with a drawing that is already drawn and we just copy it, so we just follow the dimension, follow the lines and the curves and the circles, art, whatever in the drawing, and we just copy it to draw it. So we learn using this type of drawing, we learn how to use the basics of AutoCAD. Now we will speak about something else. If I have a shape or I have an object that I want to draw it or express it using technical drawing, then I will go further for orthographic projection. Orthographic projection, as I see here, yes. So the theory of orthographic projection that I have to graphically represent a 3D object. I see, as I said before, there is the three things of the view or the object: the plane or the surface, and the edges and the corner, these corners. So if I draw it using a view of 3D to view, I will just draw the edges that represent these features of any object. Then there is something called that line of sight, that when I see the object I see it with my eye, and what I see from the object is the plane or the surface that's first come to the least distance between me and this plane. So of course there is some planes or some surface that I can't see if I look to this cubic from this side. I will see this surface, but I can't see this one, or I can't see this one, or the other one in from the back, or the under the bottom. So there is some surfaces on some edges, some points that I can't see, and I can't have a look and have information about it. However, I supposed to express my object clear. That's why they say something about how to take all the views and draw it. So when I look to my object from this side and from the upper side and from this side, I can express all the sides and all the information in all the dimension about my object, so I can re-implement it. If it is an object or a building or something, I can re-implement it using the drawing that I have in my hand. So there is parallel projection and converge projection. Parallel projection, that's I take the all the dimension exactly the same. Converge, that I take something from the projection to that's there is a scale, or there is a lower in size and dimension, or higher in size and dimension. So one what I can see from here, that if I look by a view or something here and here, if I look by a flow, if I flow something, or my eye have a degree of seeing the object, I will see some of the other sides that I don't see it usually if I see 90 degree. So like this here, if I go directly like this, I will see this exactly the dimensions of this dimension, this from this side. However, if I go from this side, I will see something from here or something from here. So what I am saying, that we usually go have a line of sight that is perpendicular perfectly perpendicular to the object. So I want to see this side or this plane of the object, and it is my eye will be parallel or directly perpendicular to the object that and the surfaces that I see from this object. Okay, so that's why here, if you look and which is rotated here, then you will see something from this side. However, if you see perpendicular or directly, you have a 90 degree to the object, you will just see one shape. Okay, however, if there is some degrees in the shape that you have, you will see something else. Okay, so we will work with the multi-view drawing. The multi-view drawing, not the pictorial or perspective or other things. So the advantage of multi-view drawing, it's accurately representing the object and the size and the shape of the drawing. Okay, so as any object we have in effect in reality, this object that we see here, we have how many sides or how many views that I can draw. This side and the other side, the top side and the bottom side, and the front and the back side. So now we have how many? We have six sides. Six sides to draw and to represent this object. However, the drawing of six sides or six views for any object is much harder, and it costs much than you think. They normally represent any object in three views. Three views is sufficient to represent the visible line and any hidden line in the opposite view. For example, if this is the front, the back view from other side, if the this is a symmetric object, so the front is the same exactly as the back. So any line that is exactly the same at this line, it will be not shown because it's the same line. However, if there is something hidden, for example, there is a circle from the other side but I can't see it from this side, this circle will be represented in the correct or corresponding side as a hidden line. We will go to the in further details in the in future about the hidden lines, but that's why we just use three elementary sides that we can represent everything in the object that we have in hand. So now if you see here, any object have a width, have a depth, have a height. This is the main dimension of this object. And here if you see, there is the, if I see from this side, and this is the plane this is the plane, or that this is, we call it top view, and this is, we call it side view, and this is, we call it the elementary or plane side. This side, if I want to represent it, what I can see first. So this is what you ask yourself, what I can see first from this object that gives me the first surface, the first line, the first corner that I see. If I see from this side, I will see that there is this line. Yes, this is the first surface that I face. Yes, so I draw it using the dimension of this shape, which is very easy. Now if I go and I am perpendicular 90 degree to this side, from this side, so what I can see else, I go further, I don't see anything. I don't because if I make a line perpendicular to this side, it will be this side it will not have any effect. I can't see it if I stand here, or the viewer, or the man who, or the person who will draw this object, if he is here, he can't see this side, or he can't see his side, this side. Imagine that is this is like a very large building or something, infinity, so you can't see any of the other sides. However, if you go from this side, what you will see first, I will see this rectangle. Yes, I will see this rectangle. This is the first. I will draw it first, which is very easy, which have this dimension. It's corresponding to this dimension because this is the corner that's connecting to the two surface. Yes, so the same dimension, but this dimension is the depth, so this is different. So now if I go further, what I hit second, surface this surface. Yes, so this surface is the second surface that I face, so I will draw it again. This is one of the side, and this is the other side, so I will draw it. As you see, you go up by the height, the same height here in the side will be the same height in the plane. So these, both of them supposed to be the same height, but the depth here is different. Here we see the depth, and the height. Here we see the width and the height. The other side is the top view. When I am in the top of this shape and I look perpendicular to it, I am parallel with the shape, so I can't see any other side. But what is the first from where I go from? I go from this side, so I hit this surface first. This surface first, I have this dimension, so I will draw it here. So this is the first surface. What is this edge? This edge is connecting this surface by this surface. Where is this edge in this surface? Here, in this side, the plane side, here. So this one is corresponding to this. So if you take some useful line or helping line, you can just draw this one easily. Another thing, if I go down like stairs, I go down to this one, this next one, this one, and the corresponding one from the other side. Yes, both of them are corresponding to this place. Yes, because this one here, if you see, the this edge is connecting this surface, second surface, with this surface, the surface that we see from the plane side, plane view. So I see this surface and the other one, and I can draw it, but it's, what is the width of it? It cover the rest of the width, the highest width of the object, and the tall is the depth of this one, is the depth of the. So now I represent everything in using orthographic projection. I represent everything in my view, in my object. Now let's go to the other one. Yeah, see, let's the same idea. I have a front, yeah, front view, right side view, top view. So the front view, I go from this side. What I can see here from this side, I see the first, I see this surface, so I draw it using the dimension of it. I draw, then I go deeper. What I see, I can't see this. Why? Because it's like I walk on it. If it is just something like a stairs, I walk. My eye is not perpendicular to it. There is, I can't see this. I can't see this only. So when I go further, I see this surface. Yes. So I will draw it. Anything else? No. So now from this side, the right side, what I see? What I see is this surface, small, this one. Yes. Anything else? If I go down, no. If I go further in the depth of the object, no. So I will just draw this side. Yes. Here In the top view, what I see, I go from the observer is above the object. He will see this small size, small surface first, so he will draw it. Then this surface from this point to this point to this point to this point. So this one, as you know, as I said before, the width of the object is the same here, so you supposed to, when you draw, you supposed to be all of them symmetrically and vertically. If I connect a line from this point to this point, it's supposed to be a vertical line. And here also, every point have a corresponding point here and here. Every point is have a corresponding point here and here. So the drawing is not actually this one in one sheet and this one in one sheet and this one in one sheet. No, all of them supposed to be drawing corresponding to each other. So if I have a line here, I will see this line as a point here. If I have a line here, I will see this line as a point or a line here. Okay, so that is how we can draw. This is how, this is another view. If the observer is not this side, he will take all the shapes that's vertically or parallel to him in the line of sight, and this one and this one in the top view. I think this is very clear. This is much easier than copying work, and all the drawing is you just depending on the your imagination and your not your observatory sense. But it's easier to draw, and usually we don't have a hard drawing or hard effects or skills to draw. Just draw what you see. Here he explained how there the other sides, there is 6 sides also, but we don't usually go with it. So here we have a top, front, right side, left side, rear side or the back side, and the bottom side. You usually go with this one, this shape, and we draw it exactly the same. Usually we leave a square here, a hidden square. So this point, we start from this point, so at least you leave 2 centimeters and 2 centimeters from here and here, 20 millimeter, 20 millimeter, and you start, and here also, and here also. So all of this point, if I extend the line from this point to this point, I will mark and match the same dimension in the other side view. Okay, now there is some edge surfaces and for examples. So this is like another example. If you have this shape and you draw the multi drawing, if you see from this point, you will have this point here, here, and here. What I can draw from this side, see, you can just copy this side like this. If there is anything else from the other side, no. What I can see from this side, I can see this side here, and I can see another one here downstairs. So if I draw it, I will see that this side here from above, you can see that there is this shape, the large one here, that one, see, and that one, and that one, and that one. So if you extend this line to this side and extend the same line here and extend the same line here, same line here by the width, and here also, but I will draw. However, I see here that there is a hidden line here, the dash line. The dash line corresponding to this line. If you see, there is a dash line in red because this surface, a small surface, this one, it's not clear here. It's not clear. If I go from above, I can see that there is an empty space under. It's not a solid until the end. So this line, I draw it as a dash line in the space that is corresponding to it. So how I can get this dimension by go by this dimension, and this point is corresponding to this point, and the other side is this point here, which is this point, as you see here in the above glass box concept. Okay, another example. This is very easy example. He start from one line, he draw it like this. If you see from this side, you will draw B and you will draw F, this line. From the above side, yeah, this is inclined line. Inclined line, you just see it one side inclined, and the two side is like a rectangle, but different in shape, different in dimension. Why? Because it you take the projection of this inclined line, not itself. So you take it itself in one side, this side. If you I see from this side, I see this line, the same exact dimension of it. I see this line, and I see this line, the connecting line. Yes, this is what I see from this side here. However, from this side, if I go by a helping line like this and a helping line like this, I will see this one, the one that in the after, or this one. This one is the same already, this one. So I take this line and I take this point. So I just draw a rectangle here, and the same from the above, like you said. Here you see that this point and this point and this point, the red line is corresponding to this two, and this line from the one shape. So take it as a concept. The inclined line is usually represented by an inclined line or inclined plane, represented by an inclined line in one view. The other two view is a rectangle, okay, representing the two dimension of this plane. Here the same idea, we have two inclined line. Okay, so what we can do, we take the first one. If I see from the beginning from here, I see that this one, I see there is an object there on the other line. I see what? The other line I see a rectangle, a rectangle from the other side. So this is the most concept. Here the same idea. This one is easy, but here he just show you how to draw the inclined line. This inclined line, as I see from this side, is a rectangle. From this side, it's this inclined line or oblique plane, it is inclined in two dimension. So from this side I see it inclined, and from this side I see it inclined. How I can take this information? I will just draw the dimension, the small dimension that I have from this point to this point. I just draw it as a line. Okay, here the projection of a curve line. The curve line, as I said in the inclined line, the same idea. It's showing up as a line in in two view, and a curve in one view, only in one view. Because if I see from the above, I will see a curve and one line. That's it. From the here, I can't see a curve. I just see there is like a column here or something. So I just see a small an extension to this line here to this point, and from A to C I just see a line, and that's it. From the other side, I see from A to B a line, not an curve or inclined line or whatever. So the inclined line, the curve, if it is vertically or represented in one view, it represented in the other two view as a line, as a small line, or as if it is 3D, then you will see it as a rectangle. Okay, here, as I said before, you see that's the part of the cylinder as a small arc in the one side. The other side is it is a rectangle. Let's say that is rectangle, assume it, and this side is a rectangle. Okay, so what we can see here, this is the transferring at depth, the transferring of a smaller line, but this is the opposite, which we should throw the top view here, the front view, the right side view, and the top view above each other. Okay, so here there is some examples about the drawing of these circles, sorry, about the arc and drawing of the arc. I asked you to draw this, take it from here, from the lecture, and try to draw it in the AutoCAD. So you practice in something that is clear to you, so that you know how is it. It assume the dimension. Try to assume the dimension. See, this is very easy. I will just, this is, he draw the line, the end of the line of this object, and the end of the line of this object here, the end of the curve, not the inside or the beginning of the curve, the end of the curve. And here is the end of the curve, the second curve, so it appears like a line in the other two sides. Here the end of the curve, not the beginning of the curve, and here also the end. So he treated in the other two view as non-curve, but in one view it gives this information that this is a curve. The same idea is here. Okay, here is the drawing of this curve. I think this is 1 and 10, 9 and 10 is also in the I will give it to you by dimension. So here, as you see, this is the circle. That's, if I see from the top, you see the circle, and you see this dimension. From the front view, you can see what you can see, a cylinder, which you can represent it as a rectangle, but this rectangle is cut it in smaller dimension here, and there is some this surface, small surface, so you just use this view. The other view, from this view, you can see the beginning of this small rectangle. Okay, this small rectangle, which is represented to this dimension. Yeah, and if you return back, you will see what you will see, another rectangle, and it cut it from inside, so like this. See, here the same idea, but here this one is not connecting to the end of the shape, but here it's connected to the end, so like this. Here it is, this line is have a 90 degree here, but this line is not having a 90 degree. This is like touching the circle from outside. It is making a tangent of the circle. So in the other, the front view, you will see an extension. You will see an extension. This extension until the point that it's touching the circuit. Here it's where is the point is touching the circuit. This is the end of this shape. Okay, and here it's the same idea. Here from this side there is this shape, small rectangle, but I see inclined oblique or inclined plane here, this one. So this one, because it's inclined, why I know that it's inclined, because it have higher than 90 degree with this shape. That's why here it have a 90 degree, but this shape here it's have some other side that I want to see it. So from the beginning here, from the beginning of this small the first one to see, to the end, there is a small inclined or small angle, so I see this one. That's the why I see this one, and I see this one. Try to imagine what's happening and what you have. This one is to the side, one side here, like this, to the one side. So to one side you will see one small this one you will see one small, and because this is a very large inclined surface, you will see it here. This is the difference between this one and this one. Here you see that there is no one inside, and the one in the beginning is the same actually as the radius diameter of the cylinder, so you can't see anything here in the between. See, from the beginning to the end of the cylinder. And here it's because it's from the beginning to the end, it's touching the cylinder in the exactly the half of it. See the difference? I ask you to study it more to see the differences and draw it. Okay, I think this is just for yeah. Yeah, the center line, we draw a center line. This is about the how the touching of each the there is some surface that's not connected to some surfaces, but we need to represent it in our view. So like this here, he said that here you see this one, if I see from the plane of this is this plane, I see from the front view. So this one I draw it, okay, with using visible line, this one, the thick one. But I want to draw that if I go further from the other side, there is a small one here. Yes, how I can draw it? That line is the same, this one, and that line is going with this one. So if you have a visible line and the hidden line, the visible line go is the represented one. Okay, so here, yes, here there is one line that is not connected, this one. There is another line here. Imagine that if you see from the other side, there is another line here connected to the end of the shape. So I will represent it by a dash line like this, but this line is not connecting to anything from this side, and it's not connecting to this line, of course, so I will leave a space. However, from the other side it's connected to the line that's vertical, so I will join it. See, there is a small difference between this one. There is he leave a space here, but here it's joined. Here is the same idea, but it is inclined line. So from the other side it is joined, but from this side it's not connected to anything. So the shape from the other side, that's here, this point, as you see, it's not connecting to anything. And if I connecting, this meaning that is connecting to this one, for example, but it's not connecting, so I leave a space. The same idea here, the shape that from the other side is not connecting to anything, not connecting to a vertical line, not connecting to any lines, of course, so it is lived in the space. So you leave a space, that's meaning that I have a hidden surface or a hidden plane that's not connecting or connecting to the other plane. Okay, this is like examples, another examples. You can the center line expressing the circle that I see before, but the center line is not leave to the end of the time. You will just leave a space if there is two plane above each other. You just above, so you representing this circle, and this is the circle. So in here you will just leave 3 to 4 millimeters outside the drawing, 3 or 4 millimeters, so you don't, this is like a rule, so you don't make it 400, 300 or 40 or 30, just outside the drawing. Okay, yes, now I finish here. So If I go to the drawing here, I hope it's working. As I said, the drawing of this line, there is some minor rules that I will mention in this in the AutoCAD. Yes. Oh, I think it is clear. Okay. Yeah. So if I want to draw the orthographic view, what I do first, I should cut off my drawing. For example, I will write 200, and I will draw 200 here. So I will move this one. Sorry. Okay. I draw here a line, and from the beginning I will go to the center of it and draw another line. See what I did here is just uh, making the 3 or 4 places that I will draw inside. Then I will have something else. Now as I draw, now I will draw here the front view. Here the front view. Here I will draw the top view, as I said before, and here I will draw the right side view. Okay, and all of them supposed to have as I said many times, if I draw something here, for example, if I draw here 20, I draw here for example 30, return back 20, return back. Okay, if I draw something here, I can't open my drawing whatever I want. So I should follow that from this point. It should follow the corresponding point here, and the end of the shape also. So every point here have something inside, have something corresponding here and also here. So there is a small rule that I follow. I will delete. I will begin my drawing 20, and I go by 20. Okay, I think 20 is very large. Okay, let's make it 10, not 20. So 10 and 10. So my drawing is not less 20, 20, 20, and closing. So what I do, if I have something like what I draw before, I have for example a line for 20, so I will begin from this point. So my drawing is like this, 20, and go down for 30, and go like this, 20, and go above. Okay, maybe I have something here above 5 for example, or something, I don't know, 7. Okay, like the shape that we see before. I will not draw the full, but I think the idea is clear now, that everything is here, that supposed that this point for example supposed to have a corresponding line or point here, and the same idea here. Okay, because and I will not accept that you draw for me the front here and the right side here, top here, top here, top here. No, the right correct rule for drawing. The top view is here in this view above the front view, and the front view have in his right side the right side view. So this is a topical or typical arrangements for the drawing. So if I make a line like this from this point here, and I write it, for example, 100 tip 45. If I draw a line here, I can draw, maybe I can draw the other side. So say, see, this one's supposed to be 20, I think. This one, for example, let's make it 40, 20, and okay. So this point supposed to have a corresponding point in here. Okay, so this one is supposed to be the same idea here. This one is the depth or something. So supposed to be, if I connected the line, because it is 45, so 45 from this point, 45 from this point, so it will be here. So if I, let's make it here, if I connect a line like this and connect a line like this, here, as you see here, this line is how much to this point is, I don't know, I don't care what is to this point, but from this point to 10, this point supposed to be corresponding to this point. If I make this line is color different, sorry, and this one is different. Okay, so here, and also this one, to make it more clear, yes, so the point, the end point here, this is supposed to be the end of the shape, my shape, I don't know what it is, but here this is the corresponding point to this. What to know now? If I draw from this point to here, supposed to have 40, exactly 40, and now what I have, because this point here is corresponding to this point, so I represent this tall or this dimension exactly in this side by using the mirror. This line is called the mirror line because it's like a mirror. It's 45, so it's representing all the dimension exactly here. That's that's like a checkup for you. You don't have to draw this, or you don't have to draw every to use also the mirror. You have to draw only the front view, the right side view, the top view only. Okay, I hope this is clear. I will give you some examples, and this is the end of my lecture today. Thank you.